In this section, we will talk about the precise definition of a limit. So first off, let's think about what a limit is. If we have a function f of x, and we say that the limit of the function f of x as x approaches a value of a equals to L, then what it means is that if this is your a value, this is your x value, which is a, as we get closer and closer from the left and the right to x equals to a, then the function is going to get closer and closer to a y value of L. Okay, so once again, as we get closer and closer to a, then the function gets closer and closer to a limit L. So the precise definition of a limit says that if f is a function defined on some open interval, so it has to be defined, of course, that contains a number a, then we say that the limit of f of x as x approaches a is L. That's what this is. As we get closer and closer to a from both sides, the function approaches a limit L. And we write that the limit of f of x as x approaches a equals to L. Now, the precise definition says this is true if for every number epsilon greater than 0, there's a number delta greater than 0, so that 0 is less than x minus a less than delta, then f of x minus L is less than epsilon. So basically, if you look at this graph here, remember that absolute value represents distance. So if this is a, then we have a plus delta and a minus delta. So the distance of the x values is getting closer and closer to a. Then there's a corresponding epsilon, so that the distance from L, the limit, is getting closer and closer to L. So as this closes in, this vertical, the y value is close into L as well. Okay, so this is what we're going to work on. Here's an example. When demonstrating that the limit of 4x plus 3 as x approaches negative 2 equals to negative 5, with epsilon equals to 5, which of the following delta values suffice? Now, looking at this, it looks kind of scary, like how do you even start this? But we always start with the precise definition of a limit, which says 0 is less than x minus a less than delta, then the absolute value of f of x minus L is less than epsilon. So let's use that. So let's focus on this part, the x minus a. So a is going to be the value that x approaches, and our limit is going to be negative 5. So what we're going to do is we're going to say that for every epsilon greater than 0, there's a delta greater than 0, such that 0 is less than the absolute value of x minus a less than delta, then absolute value of x minus f of x minus L is less than epsilon. So let's plug this in. So we know that, let's start with the f of x minus L. So let's start with the function, because this is what we're trying to show. So the function f of x is 4x plus 3. So this is your f of x right here. So according to this formula, we have the absolute value of f of x minus L. The limit is negative 5. So we have the absolute value of 4x plus 3 minus negative 5 is less than epsilon is given to us as 0.5. Then whenever, this is true whenever x minus a, so a is negative 2. Remember, a value is the x value that the function approaches. X minus negative 2 is less than delta. Okay, let's simplify this. So the two negatives, they turn into a positive. So 3 plus 5 gives you an 8. So you have 4x plus 8 less than 0.5. Whenever, then these also turn into positives whenever x plus 2 is less than delta. Now we can factor out a 4. So if you factor out a 4, we're left with x plus 2 less than 0.5 whenever x plus 2 is less than delta. Now, as you can see, what we're doing is we're trying to make these two equal. So if you divide both sides by 4, then we have the absolute value of x plus 2 is less than 0.125 whenever x plus 2 is less than delta. So we have x plus 2, we have x plus 2, which means our value of delta is going to be 0.125. So because we can pick any value of delta that's less than 0.25, we have to pick all the values that are less than 0.125, which is 0.125, 0.0146, blah, 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 0.015625, And those three values are going to be valid since they're all less than 0.125. So basically what you're going to do is you're going to start off with f of x minus L. This is your f of x, that's your L. And then you're going to set up your x minus a in absolute value less than delta. And you're going to just make these two look like each other. That's the premise of this. Let's take a look at another example. So let's identify all of our parts. So this is our f of x, which is x squared minus 10x. Our L is negative 25. And then this is our a value, which is 5. Okay, so if we have our f of x minus L, our f of x is x squared minus 10 minus negative 25 less than epsilon, whenever x minus a, which is x minus 5, less than delta. If you simplify this, we get x squared minus 10x plus 25, the two negatives back to back, whenever the absolute value of x minus 5 is less than delta. And again, all I'm doing is I'm plugging into this formula. We have f of x minus L, that's your f of x, that's your L. So we have f of x minus L, and then we have x minus a, which is x minus 5, and that's going to be less than delta, this first formula here. So if you factor this, we're going to get x minus 5 squared less than epsilon whenever x minus 5 is less than delta. Now to undo the square, we can square root the x minus 5. So we get the absolute value of x minus 5 less than radical epsilon whenever x minus 5 less than delta. So now that we have the x minus 5 and x minus 5, we know that delta has to equal to the square root of epsilon. So we can say, since delta is equal to square root of epsilon, we can say that 0 is less than x minus 5 is less than delta, which is the square root of epsilon. This homework is pretty short, and it's similar to these examples, so hopefully it should be pretty painless.